hunger has, over time, created huge man-made reservoirs, either as underground mine voids or as backfilled open-cast voids. As these voids fill up with water, they create a unique problem to the mining industry with regards to the safety of people working in the mines and the environment, should the void spill to the natural environment. The mining industry relied on a meander of solutions to the problem over the years, which included studies on reusing the mine water for irrigation and releasing the water during high river flows, which dilutes the mine water. The use of evaporation ponds and storage in previously mined out voids were also explored. The solution, however, did not address the fundamental concept of sustainability. The National Water Resource Strategy from the Department of Water and Sanitation places strong emphasis on water conservation, sustainable resource utilization, protecting ecosystems, and ensuring equitable use of the resource. Exxaro Matla is an underground coal mine which stretches over an area of approximately 22,000 hectares. Over the years, the mine has gradually been filling up with water in its mined-out underground cavities. This water has been one of the mine's top safety risks, especially during the rainy season. Numerous solutions to this problem were identified by both mine management and technical specialists. The only sustainable solution that was eventually selected was the construction of a large-scale water treatment plant, a plant that could remove the water from the underground cavities and consequently remove any contaminants before releasing clean water back into the environment. With that said, we proudly present the Exxaro Matla Water Treatment Plant. The water treatment plant stores water from mine 1, 2 and 3 in the raw feed water tank, which is essentially the starting point of the water treatment plant. As water is pumped into the plant from the feed water tank, a flocculant is added to the water to bind the suspended solids present in the contaminated water. This water is then fed through the bottom of the sand filters, which traps the suspended solids and allows the clean water to emerge at the top of the filter and overflow into the launder. The clean water is pumped to the filtered water tank, ready for the next step. The dirty or backwash water is pumped to the drain sump, and from here it is pumped to the backwash recovery unit, where a flocculant is once again added in order to bind the suspended solids. The solids settle in the clarifier and the clear water flows into a weir where it is pumped back to the feed water tank. In the next step, the water is pumped from the filtered water tank to stage 1 cartridge filtration. 120 polypropylene filters are used in the cartridge filtration system. From the cartridge filtration system, the water is pumped to a stage 1 carbon filter. The carbon filtration system makes use of 360 activated carbon filters to clear the water of odors and undesirable tastes. From the carbon filtration system, the water is pumped into 3 stage 1 reverse osmosis skids to separate salts. The reverse osmosis process uses pressure to push the water through the membranes, which filters salts from the water. Once the water has passed through the center of the membranes, it enters the clean water manifold, and from here it flows into the river discharge tank. The brine is then sent to the splitter box. The brine water enters the splitter box and flows into the reactors and then the clarifiers. The reactors aerate the water by air being fed into the water via nozzles located at the bottom of the tank. The air agitates the water, which enables the formation of calcium carbonate. The calcium carbonate then precipitates and forms crystals. Once the water has filled up the last reactor, the water flows over the top of the reactor container into the clarifier container. These crystals accumulate and form a sludge, which is then pumped back to the splitter box. The clear water flows to the clarified water tank. From the clarified water tank, the water is pumped to the ultrafiltration unit to remove any remaining particulates and suspended solids. The clean water is then pumped to a secondary carbon filtration unit, with the backwash water being pumped back to the splitter box. From the secondary carbon filtration unit, the water is pumped to a secondary reverse osmosis unit. The clean water then flows into the clean water or permeate manifold, and from there it flows to the river discharge tank or to the potable water tank before being disinfected. The brine water resulting from the secondary reverse osmosis flows to the brine pond, and a portion can be recycled back to the splitter box. As per the Exxaro vision of being a powerful source of endless possibilities, there is a continuous drive to investigate how the treated water could be utilized by external users and benefit South Africa. Eskom could utilize the water and therefore cut back on its current usage from the Department of Water and Sanitation scheme, thereby creating an opportunity for other users to link up to the Department of Water and Sanitation scheme. The water could be supplied to a local municipality, thus allowing the municipality to decrease its demand on the natural resource. This will allow for integrated development planning in the region and the equitable redistribution of water as a basic human need. Releasing the water to the Olifants River system will enable the downstream platinum industry to grow and create much needed job opportunities in that sector. Exxaro, powering possibilities.